Welcome to this session by Turbulent Flux, real-time virtual flow simulation to monitor and optimize your production. This is a session about the digital transformation and the hybrid flow simulation approach by Turbulent Flux. Turbulent Flux is a software company out of Oslo, Norway. We were established back in 2016, and today you will meet our delivery manager, Sigurd Jevne, and our senior data scientist, Songchang Yang, and me, Kjetil Roe, one of the founders of the company. Turbulent Flux is all about software for real-time oil and gas simulation, for upstream production monitoring and optimization. We have developed our own transient multi-phase flow simulator that we combine with machine learning to deliver the hybrid flow simulation approach, or the digital well twin, as we call it. Turbulent Flux has a global market with clients in the offshore industry and in onshore, unconventional and conventional oil and gas industry. We have been working with partners since day one. Wintershall, Europe's largest independent oil and gas company with operations globally. For them, we are running our virtual flow meters for a full field offshore Norway. Pioneer Natural Resources, the biggest and the most efficient operator in the biggest oil field on US land, and arguably the biggest oil field in the world. For them, we have deployed our virtual flow meter solution. Petronas, the lighthouse of the southeast. With them, we have deployed both virtual flow meter solutions and wax deposition modeling solutions. So, what is this digital well twin all about? It's always connected and always available. It provides real-time flow rates at unprecedented accuracy. This is the basis of the solution. You might call it virtual flow metering or VFM. We provide you oil, gas, and water rates at unprecedented accuracy to help you optimize your production and increase the production. Monitoring and visibility. Our solutions give you insight into the production flow at any point within your well. This makes it possible for you to understand what is going on and make the right decisions quickly and avoid unwanted happenings, hence reduce downtime. Look into the future. Our product have both what if and scenario functionality to plan your operations, to troubleshoot. What if I turn this valve? What if I shut in this well? What happens in 5 minutes? What happens in 5 hours, 5 days, or 5 weeks? We give you the opportunity to try out and plan your operations to optimize your production. One of the unique features about our technology is the self-adjusting capability. That is to provide you flow rates and other information at unprecedented accuracy over the lifetime of the field. So our simulation models adjust to the changes in production and provide rates that actually you can trust over time, and also reduce or remove any need to maintain the simulation model. That's all about reducing the cost. We are a cloud solution and highly scalable. It's all about standardization and automated workflows. Go from one well to full field deployment in very short time. Monitor each well and your full field and have complete control. Compared to comparable solutions, it is to reduce CapEx. Compared to your current operations, it's to reduce OpEx. So all these capabilities helps you to increase your production and is a key enabler of the digital transformation of the production side of your company. So we are cloud native. We are utilizing the data from the sensors that are already there. That can be pressure, that can be the temperature, it can be your virtual, it can be your flow meter, it can be pumps, it can be any equipment. It is a hybrid model combining our in-house transient multiphase flow simulator with machine learning. That is to utilize the benefit of both and reducing the weaknesses of each. Songchang will tell you more about this later. We are a completely open system that is easy to integrate with your operational systems. So we provide real-time actionable insights into your daily operations to help you increase your production and make your operations even more efficient. So I leave it over to Sigurd.
Thank you, Kjetil. Virtual flow metering is estimating oil, gas, and water flow rates based on existing instrumentation, physics-based models, a steady state or dynamic simulation model of the asset, and a reservoir fluid model, machine learning models, and optimization algorithms. Various virtual flow metering concepts exist, most either physics-based or machine learning-based. Our FLUX VFM is based on a hybrid approach, combining all of the above. It's self-adjusting, meaning that it's calculating updated reservoir properties, gas-oil ratio, and water cut, typically at the daily frequency and fully automated. The figure shows a typical well with downhole, wellhead, and downstream choke sensors. All of these are not necessarily required. We may use machine learning to generate virtual sensor values to replace missing physical sensors, for example, a downhole pressure sensor. Machine learning is also used to provide inputs to the optimization and the simulation, as Songchang will discuss in a few minutes. Here you see a visualization of phase flow rates and the downhole pressure calculated by the VFM. As you can see, our FLUX VFM is fully dynamic. I'm now going to share some VFM use cases that our clients have shared with us on how the FLUX VFM is adding value in their daily operations. Backup for multiphase meters. If multiphase meters are installed on every well and the VFM is running in parallel as a secondary measurement solution, the VFM is ready to take over if the multiphase meter is out. VFM and multiphase meter combined. A low-cost alternative to installing a multiphase meter on every well is to let the multiphase meter measure the commingled production from several wells. VFM may then be installed on each well, and a reconciliation analysis will ensure that the sum of the VFM rates matches the multiphase meter rates. Late life. One of the strengths of our technology is that it has proven to work well in typical late life scenarios, such as at very high water cuts. We have fields online where we're successfully providing oil and water rates in wells with up to 99% water cut. This unlocks all the other use cases for typical late life scenarios. We're now going to go a bit more in depth for two use cases: fill the gaps between well tests and increase production in gas lifted wells. Fill the gaps between well tests. If a test separator is installed but no individual well flow measurements, the VFM may be used to fill the gaps between the well tests. With, for example, as few as 6 wells sharing one test separator as shown in the figure, the gaps between each test are long. The output is the VFM flow rates. The objective is to fill the gaps between the well tests, and the value is access to flow rates 24/7. Also, significant time can be saved on allocation calculations. Increase production in gas lifted wells. In this example, a test separator is again shared between several wells with no individual flow measurements on each well. The output is the VFM flow rates. The objective is to use VFM oil rates as input to a gas lift optimization workflow, as some of our clients are doing. The value is to distribute a limited lift gas volume to optimize total oil production and thereby increase the overall oil production. And now, our senior data scientist, Songchang Yang, will take us through our hybrid approach, how we're combining physics and machine learning in the FLUX VFM.
Thank you, Sigurd. In Turbulent Flux, we apply a hybrid approach by combining physics and machine learning. When solving complicated science and engineering problems, the physics experts start from first principle physics to model the real world. When the physics model is good, it is very good and predictive. It can simulate different scenarios and require little data to calibrate, which means it can last very long over the operations. But the challenge here is that the physics model sometimes has very high complexity and high computational cost. And in real world, sometimes the necessary sensors become malfunction and not available. The machine learning experts start from the data and train machine learning models to make predictions. This computation is very fast and very scalable. It can also use all the available data that's not necessary for the physics modeling. But the challenge here is all about the data, especially in the oil and gas industry. It usually has low data volume, little variety, and the machine learning model has limited exploration compatibility. And sometimes the non-stationary process change can make the machine learning model no longer accurate. So, if you look at the benefits and challenges on both sides, you can see that they can compensate each other. For example, the predictive power of the physics model can help the data issue in the machine learning. And the machine learning model can reduce the complexity in physics and even improve the accuracy. In the next slides, we will show you an example of how we applied hybrid modeling in the real world. But first, let's talk about the machine learning operations. In Turbulent Flux, we develop an end-to-end workflow to make the machine learning modeling more scalable. First, we develop an API to fetch the data from our client's data platform. And next is the data preparation. We developed an automatic process to analyze the data. Here, we heavily leverage our domain knowledge to improve the data quality and enhance the data. Then, we apply a data-centric approach to train the machine learning models. These models will be deployed on the cloud and connect to the real-time data stream from our clients and make real-time predictions. And these predictions will fit to the applications and used by our clients. This workflow is cloud native and very scalable. Okay, here is an example of our hybrid modeling. To the right, our physics model can calculate the oil, water, gas rates based on some pressure and temperature sensors. It means solving the Navier-Stokes momentum equations and implementing the inflow performance relationship and also the heat transfer models. But in some use cases, especially in late life offshore oil field, that the water cut is very high, up to 99%, and in some unconventional oil field, that the water cut change rapidly. In these scenarios, the physics model is unable to determine the oil-water split accurately. So we apply the machine learning to the left to compensate the physics. Here we use machine learning to predict the water cut. And during the modeling, we applied physics such as choke model, tube model to do feature engineering and data enhancement. Which means we applied physics to improve the performance of machine learning. By combining both sides, we have a hybrid virtual flow metering with exceptional performance. So our physics model can calculate the gas and total liquid rate in a very good level. And we use machine learning to predict the water cut to split the water and oil. Combining them together, our hybrid FLUX VFM can achieve three-phase flow rates continuously above 90% accuracy. Here is an example show the comparison between our predictions and the measurements. They are in very good agreement over a very long period of time. And this kind of approach is especially very important in late life oil field that has high water cut and unconventional oil field that the water cut change rapidly every day. That's all. Thank you very much.
Thank you, Songchang, and thank you, Sigurd. That wraps up our session today. So Turbulent Flux, a software company that provides you information about your production flow, for example, rates of oil, gas, and water at unprecedented accuracy in a scalable solution. We thank you for joining these 25 minutes with us. We hope you found it interesting. And if you need more information or if you would like to meet up with us, please contact us. You find the contact information at this page, or you can just go to turbulentflux.com. Have a nice day.
Thank you.